This is the core question. We're evaluating a simple classifier on a dataset where one class is far more common than the other. We'll look at how this imbalance affects the accuracy, precision, recall and F1 score. I predict that precision will be high for the majority class because the model always guesses the majority class. Since most of the data is the majority class, there will be few false positives. Precision is the ratio of true positives to true positives plus false positives. With many true positives and few false positives, the result will be a high value. It's almost guaranteed to be perfect. I'll get a high recall score for the majority class as well. Recall measures the ratio of true positives to true positives plus false negatives. Because the model always predicts the majority class, it'll correctly identify almost all instances of it. There will be few false negatives, leading to a high recall value. The F1 score is the harmonic mean of precision and recall. While the majority class will have a high F1 score because both precision and recall are high, the overall F1 score will be low due to poor minority class performance. It's important to keep the whole picture in mind. I expect high accuracy because the model predicts the majority class, 90% of the data. Accuracy is the ratio of correctly classified instances to the total number of instances. A classifier that almost always guesses the most frequent class will be quite accurate but misleading on an imbalanced dataset. I'm asking you to predict how well a simple classifier, the DUMMYCLASSIFIER using the MOSTFREQUENT strategy, always predicting the most common class, will perform. We're using a dataset where one class is overwhelmingly more frequent than others. 90% of the data is one class. Let's think about accuracy. Accuracy is simply the percentage of correct predictions. Because the DUMMYCLASSIFIER will always predict the most common class, which makes up 90% of the data, it will get a lot of predictions right, resulting in high accuracy. It's kind of a cheat, though. Precision measures how many of the predictions for the majority class were actually correct. If you only ever predict the majority class, and it accounts for 90% of the dataset, you'll get perfect precision because every positive prediction was right. That's a high precision. Recall tells us how many of the actual majority class instances the model correctly identifies. Since the model always predicts the majority class, it will correctly identify all the true positives in this class. So, it'll get a perfect recall, which is a high recall. The F1 score balances precision and recall. A high F1 score requires both high precision and high recall. While this model has high precision and recall for the majority class, it completely ignores the minority class. The overall F1 score will be quite low. Therefore, a high F1 score is not guaranteed. I'm evaluating a DUMMYCLASSIFIER, a simple classifier in SCIKITLEARN, on a dataset where one class is much more common than the other. I'll focus on how well it predicts the more frequent class. This means 90% of the data points belong to this class. It's the dominant group in my dataset. Only 10% of the data points fall into this class. It's significantly less frequent than the majority class, making it a challenge to predict accurately. I'm tackling a classification problem with two classes, and using a DUMMYCLASSIFIER to understand its limitations on imbalanced data. Recall measures how many of the actual majority class instances the model correctly identifies. Since the DUMMYCLASSIFIER always predicts the majority class, it will correctly identify all of them. So, it gets a perfect recall for that class, 100%. Precision measures the accuracy of the positive predictions. Since the model only predicts the majority class, all its positive predictions are correct. This means perfect precision, 100%, for the majority class. The F1 score is the harmonic mean of precision and recall. While the majority class will have a perfect F1 score, because both precision and recall are 100%, the overall F1 score considering both classes will be low due to the poor performance on the minority class. The overall F1 score is more informative than the F1 score for the majority class alone for evaluating the performance on the entire dataset. Accuracy simply means the percentage of correctly classified data points. Since the model always predicts the majority class and 90% of the data is the majority class, the accuracy will be about 90%. This illustrates how accuracy can be misleading in imbalanced datasets. This is our problem. We're using a simple classifier, DUMMYCLASSIFIER, that always predicts the most frequent class. We'll see how it performs, especially with accuracy, precision, recall, and the F1 score, which are the performance metrics that need to be checked. The dataset is imbalanced, which means one class, 90%, far outweighs the other, 10%. That's important to consider. Let's think about precision. Precision is about being correct when you do predict the majority class. Because our classifier always predicts the majority class, it's 100% precise for that class. Every time it predicts the majority class, it's correct. Pretty neat, huh? Recall asks, when the actual class is the majority class, how often does the classifier correctly identify it? Since our classifier always predicts the majority class, its recall for the majority class is also 100%. It never misses a majority class example. High five. The F1 score balances precision and recall. While the classifier achieves a perfect F1 score for the majority class, because both precision and recall are 100%, the overall F1 score will be low because the minority class is completely ignored. We need to keep in mind that this F1 score is only for the majority class. This is the bigger group in our data. 90% of our data points belong to this class. This is the smaller group, only 10% of our data. This is the classifier I am using. It's a simple one that just guesses the most common class in the training data. The backquote strategy equals most underscore frequent backquote part tells it to do just that. This is what the classifier does. It always predicts that every data point belongs to the majority class, ignoring other features and characteristics of the data points. I predict the dummy classifier will get about 90% accuracy because it always guesses the majority class, and the majority class makes up 90% of the data. That's a pretty good accuracy score, but it's misleading. In this case, because it doesn't tell the whole story about the model's performance. I expect the precision for the majority class to be 100%. That's because the model always predicts the majority class, so whenever it predicts the majority class, it's correct. Precision is about the accuracy of positive predictions, and in this case, every positive prediction is correct. For the majority class, I anticipate 100% recall. Recall measures the model's ability to find all instances of a class. Since the dummy classifier predicts the majority class every time, it will find every instance of the majority class. It won't miss any. While the F1 score will be 100% for the majority class, because both precision and recall are 100%, the overall F1 score will be low. This is due to the model's very poor performance on the minority class. The F1 score, being the harmonic mean of precision and recall, reflects that poor performance, making statement D potentially misleading. I'm analyzing how well a DUMMYCLASSIFIER performs on a dataset where one class is much more common than the others. Specifically, I'm using the MOSTFREQUENT strategy, which means the model will predict the most common class every single time. This will be interesting. Since the DUMMYCLASSIFIER always predicts the majority class, it will have a perfect precision score for that class. Precision is about correctly identifying positives, and in this case, we're completely correct every single time we predict the majority class. The recall for the majority class will also be perfect. Recall measures how many of the actual positives were correctly identified. Since we predict the majority class 100% of the time, we're never missing any of them. The accuracy will be high, but not perfect, because the majority class accounts for 90% of the data. Since it is a really high percentage, the overall model accuracy will also be high, close to 90%. However, this high accuracy is misleading because it doesn't tell the whole story of how the model performs. The F1 score is a combined measure of precision and recall. While the majority class will have a perfect F1 score, because both precision and recall are 100%, the overall F1 score for both classes will be low because of the poor performance on the minority class. That's what makes the overall F1 score a little tricky to interpret. This tells me the dataset is highly imbalanced, with the majority class making up 90% of the data. This is really important to consider because it means that even a simple model can appear very accurate. I'm evaluating a DUMMYCLASSIFIER, a simple machine learning model, on a dataset where one class is much more frequent than the other. This is a common scenario, and it's crucial to understand how such imbalances affect model performance. We'll see how this affects the evaluation metrics. Let's talk about recall. Recall measures how well the model identifies all instances of a particular class. In this case, since the DUMMYCLASSIFIER always predicts the majority class, it will correctly identify all instances of that majority class. Therefore, the recall for the majority class will be perfect, or 100%. I'm dealing with a dataset where 90% of the data belongs to one class, which I'm calling the majority class. This imbalance makes accuracy a potentially misleading metric since a model could achieve high accuracy simply by predicting the majority class every time. Conversely, the remaining 10% of the data belongs to what we call the minority class. This minority class might be very important, and the model's poor performance on this class could have serious consequences, despite any high accuracy for the majority class.